Antoine. I would like to welcome you to the 350 South Campbell Redevelopment Project. My name is Antoine Hanchard. I am the project manager as well as the environmental engineer for the site. We have Jemima Benson, who's our structural engineer, Jeff Molitsky, who's our water resources / hydrology, and then we have Ben, who's our geotechnical design. So we're just going to give you a brief overview of what to expect during this presentation. I'm going to give a project background on the site, then we're going to follow that with the environmental, structural, water resources / hydrology, and all the geotechnical designs for this project, followed by a final cost estimate of the overall project. To start off with project background, this site has been around since the late 1800s, so it's seen a lot of changes of companies. Last company that held this site was the ANCO facility, and they abandoned the site about 30 to 35 years ago. So it is now an existing brownfield, and the primary concern on the site is the contamination that is there. And the city of Valparaiso would like to redevelop this region. It is located south of, if anyone knows where Franklin House is, it's located right there. So this is the existing site. So they would like to redevelop this area for more interest in the area and just future growth for the city itself. And then we also, Journeyman Distillery would also like to move into the site. So we're going to do geotech, water resources, and structural designs for the distillery needed. So this is the current site. It's been abandoned. It's not looking pretty. And then after our design is over, we would like to transform it into this rendering that we have up here. So we're going to start, and then the existing issues on site are, so for the South Campbell site, we have groundwater, soil, and soil vapor contamination. We also have asbestos in the roof that needs to be treated. And because of the abandonment of the building, safety of the building is also an issue. We also have a South Franklin site, which is a culvert, and the culvert is in poor condition and in poor soils, so that also has to be taken into consideration. So for the contaminants of concern, this is the groundwater contaminants. We have TCE and its daughter contaminants present in the water, as well as the heavy metals of arsenic and lead. The red cells are the monitoring wells where the contaminants exceeded the 2018 IDEM screening levels. And then we can follow that up by the soil vapors right here that were taken from within the building. The soil itself is contaminated, but it is below the 2018 IDM screening levels, so we will not be remediating the soil itself. This is the groundwater plume right here. So a primary concentration for the treatment is north of the site, probably 100 to 200 feet up north. So for the heavy metals, we're going to be using a precipitation, coagulation, flocculation system, and we're going to have 3 extraction wells with a radius of influence about 75 feet, and that's going to go through a rapid mix tank, and we're going to use a sulfate ion mix to get the arsenic and lead flocculated, which will be right here, and then finally into a sedimentation tank. The sludge that is produced in this will be taken care by a third-party company and then will be disposed of properly as a hazardous waste material. Once the groundwater is through the PCF treatment train, we're going to have it go through an activated carbon treatment so that we can get rid of the TCE and its daughter contaminants. And that's going to go through a filter just to get any extraneous material that's still in the water out, and then it's going to go through the activated carbon. And once that's deemed clean enough, using the sample ports, we're going to discharge it upstream of the site and reintroduce it into the groundwater. So this is the location of the train that we're looking. So the pumps are going to be located right here. We're going to have them go through piping up here, and then this is the PCF system, and then this is the activated carbon tank. So for the soil vapors, we will be looking at about 6 vertical wells, and then we're going to have them located at space within the building. They're going to go through a demister tank, and then any condensate that is created by that will be also taken care of by a third-party company and disposed of appropriately. It's going to go through a particle filter, and then finally through a vacuum blower, and then once the samples meet the IDM and EPA discharge levels, they're going to be discharged into the atmosphere without harm. And then this is the location of our wells, for the extraction wells, and then we're going to have 6 of them with an ROI of about 75 feet. Now I'm going to pass it off to Jemima, our structural engineer.
Thank you. As Antoine said earlier, we are redeveloping this site, and Journeyman's Distillery would like to have a distillery on this site. So we decided to put the distillery on the ground floor of this building and have event space with a kitchen and a bar on the 2nd floor, storage space in this building right here, and use this for for office space for any workers in the distillery. So this is an overview of what the main floor of the building looks like now as is. So we decided to leave it as is because we did not have blueprints of the building, so we couldn't get the capacity of the building itself. So we assumed that the ground floor would be suitable for the distillery. So this is how it is right now, with a stairway right here, an elevator right here, and there's another elevator down here that isn't shown in this plan. So the 2nd floor of the building, as said before, is going to be turned into an event space. So in order to create open space for the event space, I took out 3 rows of columns right here to create 68 feet of open space for any type of reception or any gathering that would be held over there. And I also took out some columns in the middle areas right here just to create a more open space on the 2nd floor. So this is a better view of how the space is going to look. So on the bottom floor, you can see the columns are very closely packed, and then this shows the 68 feet of open space right here, and shows how some columns are removed on the 2nd floor as well. So with that, I'm going to pass it on to Jeff, our water resources engineer.
Thank you, Jemima. So to begin, I want to just go over some of the requirements that we had from the owners, as well as to comply with all the standards and regulations of the City of Valparaiso's Stormwater Manual. We were tasked with designing best management practices suitable to the site. So best management practice is just basically a way to reduce runoff volumes and to remove some of what is up here, total suspended solids or total nitrogen and phosphorus from the water to make it safe to dispose off-site so it doesn't contaminate more bodies of water or contaminate any other type of groundwater. And we were also tasked with redesigning the South Franklin Street culvert. To move into the South Campbell site, we used 2 best management practices here. One is the biofiltration planters that were seen on the original 3D rendering that can be also seen here. One's along the storage building in Building B, another one right here, and another one along the office building up to, there's a shipment door there. And then we also used porous asphalt in the middle to utilize that space as a best management practice as well. We did keep the porous asphalt 10 feet away from the building to refrain from having any structural damage done to the building from infiltrating water. So to move into the biofiltration plants a little bit, this is basically what they look like. What happens is that the water will come in through the top from the roofs of the building, and they will go, the water quality volume, which is a small amount of the actual total runoff that the storm will give, will go through these planters and go through the soil, and it will remove some of those total suspended solids and phosphorus and nitrogen that are in the stormwater. They also will use under drains to transport the water, like I said earlier, to a proper and approved disposal point. They're also very aesthetically pleasing, cost effective, and can be made in tons of different types of shapes. So like we had before, we have an L-shaped one over here, and another one that is cut in 2 90-degree angles. And it does treat mostly through the soil layers. And then part of the perforated under drain will also help to remove some of those total suspended solids. These are a couple examples, a little bit better of how it works. It goes through the soil and out through and to a disposal point. And then this is basically what they will look like alongside a building. Very nice plants, very aesthetically pleasing, and really brings that Valpo experience to this site. And then we have the porous asphalt in the middle. This is basically the layout of it alongside the buildings. They have 3 layers, a surface layer that looks usually just normally like conventional asphalt would. However, underneath there's a treated permeable base as well as a storage and treatment layer. And then after that, it will infiltrate all the way into the normal soil that's on the site. They're known for really, really good stormwater management and can infiltrate most of the water it receives. They do have an overflow. There's an overflow weir right there just in case the storm is too big for the porous asphalt. The big thing with these is that they need maintenance usually twice a year to be vacuumed so that they don't clog at all. These are examples of what the porous asphalt is like. Like I said earlier, porous asphalt, an asphalt treated permeable base, and an aggregate sub-base reservoir for the water to store and infiltrate into the soil subgrade. And this is what happens when it goes through the first couple layers and will be treated by the porous asphalt. Then we move into the culvert design and we ask ourselves why it's needed. Basically, a culvert is needed to prevent water from getting onto the roadway and making the roadway inaccessible after a major storm. And it also prevents sinkholes under the roadway with water moving underneath the road. So in this profile, this is like a side view of the culvert. The black lines are the culvert, and then the orange is the embankment, the roadway up top and all the way back down, and the blue is the water line. As you can see, it does not overtop onto the roadway, and we have a good design. This is an example of what a culvert does. Just make sure that it's good on the embankment as well. And with that, I will pass it off to Ben, our geotechnical engineer.
Thank you, Jeff. Everyone's still awake? Great. Okay, so one of the challenges with the geotechnical aspects of this project was really figuring out what kind of work actually needed to be done to the site. Because a lot of the stuff what I deal with are kind of just little odds and ends that kind of clean up some of the loose ends that some of our other disciplines have already addressed. So first off, we are going to be replacing the slab, the concrete floor, within the bottom floor of Building B. And the reason we're doing this is mostly because, well, I mean, there's a couple reasons. First off, the floor is kind of already not in the best condition right now because it's a very old building. We're also drilling those wells for the soil vapor extraction. Those aren't very big holes, but we figured since we're drilling them, we might as well take out the entire slab. Also, I needed more design work, so we're going to throw that in there. So basically, I just designed a new floor for that. There's also going to be a new slab on the upper floor, so we figured we might as well replace both of them to keep it consistent. We're also going to be putting in new elevator pits in the building because we're going to be incorporating more modern elevators. The building is very old. We're not exactly sure what equipment is used for the lift system on the current elevators, but we're assuming it's not a hydraulic system, which means that we'll likely have to bring down the level of the current pits. So I've designed elevator pits now with a matte foundation and shear walls along the edges. So this is just a profile view, but there's going to be obviously 4 walls around the perimeter of this elevator pit. We're also going to be putting in a solar panel canopy within the parking lot. And the reason we're doing this is because one of our main goals for this project is we really wanted to create a staple site for Valpo in the downtown area, make it something that really caught your eye, and we thought that this solar panel design was really an innovative solution to a couple of problems on the site. So first off, this is next to the Chicago Dash parking lot. So we figured that customers of that service would be able to use this parking lot as well and use these canopies so that when they park to use the bus service to go to Chicago, their cars would be shaded from the sun, from weather, anything of the sort. It would just be kind of a very elegant solution to that. And we would also provide solar energy, clean energy, which is very appealing to the nearby building, and also potentially sell back some energy to NIPSCO. We're also going to be putting in 2 retaining walls on site So this is the northern end of the site over here. The building's here, the parking lot would be here. And right now, right here in this spot, there is kind of just a big hill. So we're going to be installing a staircase that goes from the parking lot to the courtyard where the building is, because normally you'd have to go all the way around. So there's going to be a staircase here, and then there's going to be a retaining wall here and here, because these sections that are next to the buildings are going to be higher than the stairs, so we need to hold back those soils. So here's a profile of the retaining walls. They're both going to be identical. It's going to be 15 feet high, and it's going to go 3 feet below the ground. So in total, it's going to be an 18-foot wall with a 7-foot leg with proper drainage and reinforcement. Also, finishing up with the culvert design. So right now, the culvert is about 2 blocks, I believe, to the east of our site. It's kind of just a side part of our project. But we need to replace the soils underneath the culvert because it's in very poor soils. It's Class C soils. It's mostly peat, I believe. So it's really just not good for building anything on top of it. So essentially, we're going to be excavating about 4 feet below the current culvert, take out all that soil, and then import nice silty loam. And we're going to be putting that in the bottom, installing the culvert, and then filling it on top of it with a low-strength flowable concrete to give it some rigidity, and then backfill the rest with the same material I was just talking about, the silty loam. And now to go on to some social and economic benefits. So first off, one of the biggest things is we just want to create a nice downtown experience for Valpo that people really want to go to. So I think one of the biggest benefits is that it's very aesthetically pleasing. It's a place that people are going to want to go to, and it's just going to look nice. I think that will also increase the property value of apartments that are likely to be planned for the nearby area, as well as improve the quality of life of the nearby area. The solar panels will also provide clean energy to the area, and finally, when we clean up the contamination on the site, it's going to create a much cleaner environment for the city. Finally, for our cost analysis, it'll roughly cost around $10.5 million for the final product. And with that, I'd like to invite my colleagues up for any questions or comments. Yeah, go for it.
I heard you talk about building a staircase from parking lot to some floor of the building. The staircase is not ADA compliant. Are you allowed to do that?
So the staircase is not ADA compliant, but as I said, you can actually, let me go back to that picture. Yeah, so a staircase is not ADA compliant, and we kind of messed around with putting a ramp in this area as well, but we just didn't really have enough room for it. So we kind of were looking through what would be ADA compliant. And currently, because you still can go around the building, it's not as elegant of a solution, but that still does comply with ADA regulations. So, yeah.
Yes.
Yes, absolutely. So the parking lot comes all the way down to like here. So there would be handicap parking so that you wouldn't have to park on the western end of the site and then go all the way around the building. Yeah, Eric?
So does that culvert that you're replacing always have flow moving through it, or is it?
Yes, it does.
Okay, so then do you have a plan for, you wanted to replace the soils there, right? So then is there a plan for like redirecting that flow around that current site, or how does that soil get replaced in the area where the flow is always constantly moving through there? I'm just curious.
We would obviously have to redirect the flow around for some amount of time in order to replace that culvert.
That is a great question. We did not look into that very much. I would imagine that the construction process for the actual culvert probably wouldn't be very long. It would probably take definitely less than a week. I would say max, 3 or 4 days, probably. It's not a super huge project, but I'm not entirely sure. That was just kind of an estimate. Maybe max a week, I'm not sure, but we definitely have to look into that more.
I was just curious, because I wouldn't know off the top of my head how exactly I would do it either. So.
Okay, thank you for your questions.